Hi and welcome to Quick Math on Trigonometry. Bearing is a subject of trigonometry, and it is an angle measure in the clockwise direction from its north, often with a specified distance. For example, the bearing of B from A is 150 degrees with a distance of 6 cm is as shown below. Let's now take on tutorial question 1. A person starts his journey from A by walking 30 kilometers to the east to get to B, then heads south for 40 kilometers to reach his destination at C. Draw his journey to the scale of 1 to 1 million of actual. Measure its bearing from the starting point. In accordance to the given scale, this would be 30 millimeters to its east and 40 millimeters down south. AC can be measured using a protractor, and it should read at 143 degrees. Next, I wish to formalize the basic trigonometry ratios for a right-angled triangle, where tangent theta is opposite over adjacent, sine theta is opposite over its hypotenuse, and cos theta is adjacent over its hypotenuse. I wish to revisit the Pythagoras theorem, where c squared is equal to a squared plus b squared of the given diagram. Here are some pictorial examples for where basic trigonometry ratios and Pythagoras theorem is applied. Tutorial question 2. Find x, the long side of the right angle triangle. By applying what we know from trigonometric ratios, we could identify x as 10 cm. Tutorial question 3. Find cos theta without the use of a calculator. By first identifying x using the Pythagoras theorem, we could now proceed to identify cos theta. Tutorial question 4. Find the horizontal distance between the two towers with the given information. Let x be as what is shown on the diagram, and by applying what we know on trigonometric ratios, we could solve for x being 60 meters. This allows us to know that diagonal distance from the viewing point to the top of tower A is 110 meters. Next, we let y be as what is shown on the diagram. And again, we could apply what we know from trigonometric ratios to solve for y being 55 meters. The required distance is therefore 25 meters. Next, I wish to touch on sine, cos, and tangent curves between 0 degrees and 360 degrees, which takes the shape as shown. Specifically for the sine curve, the table on the right is indicative of its sine theta being of the same values for each of the individual rows, which can be summarized as sine theta being equal to sine 180 degrees minus theta being equal to the minus sine of 180 degrees plus theta being equal to minus sine of 360 degrees minus theta. Specifically for the cos curve, the table is indicative of cos theta having the same values for each of the individual rows. It also summarizes to cos theta being equal to minus cos 180 degrees minus theta being equal to minus cos 180 degrees plus theta being equal to cos 360 degrees minus theta. This slide shows the relationship between sine and cos curves between 0 and 90 degrees, where sine theta is equal to cos 90 degrees minus theta. And specifically for the tangent curve, the table is indicative of tangent theta being of the same values within each of the individual rows. This translates to tangent theta being equal to minus tangent 180 degrees minus theta being equal to tangent 180 degrees plus theta being equal to minus tangent 360 degrees minus theta. Tutorial question 5. Express sine 50 degrees in terms of sine of another angle between 0 degrees and 180 degrees. Sine 50 degrees is equal to sine 180 degrees minus 50 degrees, which comes to sine 130 degrees. Next, express sine 50 degrees in terms of cosine of an angle between 0 degrees and 90 degrees. Sine 50 degrees is equal to cos 90 degrees minus 50 degrees, which comes to cos 40 degrees. Tutorial question 6. Find all thetas for the range of theta between 0 and 360 degrees, where cos theta is 0.5. For the positive value of 0.5, its theta would be 60 and 300 degrees. As for trigonometry for non-right angled triangle, there are two rules. Sine rule has its sine A over A being equal to sine B over B being equal to sine C over C. Its cos rule would have A squared being equal to B squared plus C squared minus 2BC cos A. Separately, the area of a non-right angled triangle can be calculated as half AB sine C. Tutorial question 7. A boat C is spotted by two observation points. At observation point A, C is at the bearing of 150 degrees and a distance of 5 km from A. At observation point B, C is at the bearing of 45 degrees and a distance of 3 km from point B. Identify the distance between the two observation points A and B and find the shortest distance C is from the straight line coast. By letting A, B, and C be as shown on the diagram, we could easily say that B is 5 km, A is 3 km, angle of A is 30 degrees, angle of B is 45 degrees. And from here, we shall be able to decipher angle of C being 105 degrees. Applying the cosine rule, we could then solve for C, which is the distance between A and B. Further to this, the shortest distance C is from the coastline is A sine 45, which comes to 2.12 kilometers. That's all for quick maths on trigonometry. If you have found this useful, do seek out our other videos under the KT tutorial channel.